Start with our first speaker, Harshwardhan, who is going to talk about Kubernetes workloads across around 40 data centers. Right? Yeah, over to you. Let's have a round of applause.
So, hey guys, I am Harsh. I will be mostly covering how we configured EKS Hybrid for a client which has around 40 plus data centers across the world. They mostly reside in US, UK, Europe, or these places. So a little bit about me. I have been in the field of SRE and DevOps for the past 3 years, and I love to play with new technologies, EKS, Docker, Linux, all those things. Apart from work, over the weekends, I love to watch movies, like animated movies mostly. Like, one of my favorite movies is Wall-E. So yeah, and apart from that, I love to do DIY stuff a lot, related to electronics, cars, all those things. So yeah, मेरे बारे में बहुत हो गया, थोड़ा काम धंधे पे आते हैं. So what I will cover is mostly how did we set up EKS Hybrid, why we needed EKS Hybrid, what is the main part of EKS Hybrid, which is the networking part. Post that it becomes a normal EKS, and what are the prerequisites for it, and what are the challenges we faced around setting it up and making it taking it up to a scale. So, what is EKS Hybrid first? Does anyone know or any idea? Okay. So EKS Hybrid is nothing but having your worker nodes on your on-prem or wherever you want, maybe a different cloud apart from AWS or anywhere. And your control plane stays in AWS. Why would you want that? There are multiple reasons. The biggest one, at least for us, was the regulatory reasons, which is our data should reside in a specific region, country, or state. Like in US, there are many states which say your data should be in a specific state, not even a country, a specific state. So, and AWS doesn't give a data center in each state. So there we had to have a data center locally, and that was not a difficult thing for us because the client which we are working with has a lot of experience in that, and they have been in the market for around more than 100 years. Like this year, one of their product got a 100-year anniversary. So they already had a huge setup of data centers across the world. So that was a good thing for us. We did not have to manage any data center level stuff. We just had to focus on the AWS part of it. Apart from that, we have a lot of ways to deploy. As I said, we were a very old company, so we had applications running on VMs, uh, directly running Kubernetes over on-prem, as well as we have also explored AWS for a newer application. So we had experience of how each setup works, and we wanted to combine it so that we can use our on-prem data centers as well as use the expertise of AWS in managing the control plane, which we did not want to do. So what we started doing is we started looking on options. And the best option we found was EKS Hybrid, because that way we just offload the control plane stuff to AWS and we just manage the workers which we already have on on our data centers. And VM.
What kind of application or workload was running on this?
These are applications related to betting, I would say. They are a major player in betting across the world. And these betting apps can be user-based trading apps. Also, multiple other vendors consume our APIs so that you get directly, like for example, there is a shop. I don't want to name anything specific, but for example, there is a vendor in the same state. They can directly connect to our data center so that they have a very good latency and all that instead of going through the AWS. So yeah, so that way we also got lower latencies compared to AWS, yeah, for our specific use cases. And
what were the latency requirements?
uh, in the start, we did not have as such. Like we wanted to first do a POC, but later on, I think the latency numbers were calculated by the team itself. What we did was we configured it for them, and they all did all the testing and benchmarking of that. I don't have the numbers as such, but compared to the current, what do you say, virtual or legacy environments, it was at par with lower overhead of managing the VMs and all that. So that way we are good with that. So moving forward on what is the architecture of hybrid as such. So this is nothing but so you have the AWS region wherein you have your EKS cluster, the control plane of it, and you can have your worker nodes there as well, because option to scale there as well, so that in case, for example, Black Fridays, many companies do that. They have their on-prem workers, which for a normal workload, but whenever they are expecting huge workloads, they want instant capacity, so they go to AWS for those. In our case, we were using AWS mostly for handling the webhooks and all that, which I'll come later why we were handling it there. But yeah, we are handling those as well as add-ons which needs to be in AWS or which needs to be in contact with EKS. To set up both the environments, we required a private link. In our case, we had a direct connect. You can have a direct connect, or else you can have a site-to-site VPN. In big organizations, it is norm that they have a site-to-site VPN at least between their on-prem sites and data on their AWS VPCs. But in our case, we also had a direct connect because, as I said, we already have a lot of data centers and we were managing few apps on AWS natively. So yeah, when you configure a EKS cluster on AWS, just the two things change. When you configure EKS, you have to enable a setting called EKS Hybrid, and you have to pass in a remote node sider, so that EKS knows what is your node sider on-prem, so it can route the traffic there. And if you are using a routable pod network, you also have to mention a remote pod sider, so that it knows where your remote pods are, or if it is in this AWS account, or if it is outside of that. Yeah, and similar things are being configured on the on-prem, wherein you just create a node and nothing to configure there. Post that, the biggest question comes in when you're configuring EKS Hybrid is which way you want to go with, a routable or non-routable pod network. So does anyone know what a routable or a non-routable pod network would be? Just by, yeah.
Routable is like where exactly it's kind of a rule book, like where we can route the traffic, not the internal one, right? We can use. So let's for the between the subnets, the other stuff.
Correct. So it is basically a table or a list of IPs or routes, wherein, for example, you want to go to 10.1.1.1. It knows through which gateway it needs to pass the IP and where the pod or the end destination resides. So if AWS provides you two options. One is set up a routable pod network, which if you set that up, it becomes a normal EKS cluster. Once that is set up, you have all the connectivities, like you can configure your EKS with ALB, any AWS managed service which works with EKS and all that. And you also have connectivity from AWS to on-prem for pod-to-pod network. So if you want to call a pod IP from AWS, that is accessible. But to achieve that, you need to have a BGP setup on the on-prem side, so that once it IP goes out of AWS, it knows on which node or which VPC or network the IP is available in, so that it can be routed to that. But in our case, we did not have the expertise, or the network team did not want to set that BGP up because they did not want to complicate their current setup. So we went with the non-routable pod network. This comes with a few drawbacks if you go with that, which is you do not get connectivity from AWS to on-prem for pod-to-pod network. Node-to-node works because that works on the VPC level or the direct route table, but for pod-to-pod it doesn't work. The other way around works, which I will come back in the next slide why it works. So remember, pod-to-pod doesn't work, node-to-node works. Apart from that, because of this functionality not working, wherein AWS doesn't call pods on-prem, you lose the functionality of webhooks working. So you need to schedule all webhook related components on the AWS end, so that it can have direct communication with the control plane. With this, you also get a few issues wherein for specific add-ons doesn't work. In our case, we recently found out that KDA HTTP interceptor add-on doesn't work because all the components in that needs to be on AWS, so that they are in constant connection with the control plane. and we have our workloads on-prem, and the interceptor needs to have connectivity with that. So that doesn't work. So there will be a few cases if you go with a non-routable network, your add-ons may or may not work, and you will have to check through all of them so that you decide the placement of each component of your add-on.
So the add-on thing you talked about, is it because EKS have control plane nodes on there in AWS, and some component is running there, and your workload or whatever add-ons component which is running on worker nodes need to talk to those pods?
Correct.
It's like that.
Right. So if the pod on-prem needs to contact to the AWS component, that works. But in case if a component wants to connect to a pod on-prem, that doesn't work. That's the issue, because from AWS to on-prem, the network is non-routable for pods. If it goes over the node, like if you open a service on node port, that might work. That works. Sorry.
Internal normal
Correct.
cluster IP service might.
Correct. So as I said, traffic from AWS to on-prem doesn't work, but the other way around works. So why is that? That's because on-prem we run Cilium CNI. CNI is nothing but a network component which handles all the IP setups, all the routing for a cluster level. Basically, all cluster level networking is handled by a CNI. In our case, when you set up EKS Hybrid, the AWS side runs on their default CNI, which is called VPC CNI, which AWS provides. And on-prem, you have to run Cilium or Calico. AWS gives you two options. They also have a customized version of Cilium, just the Helm chart, so that it is compatible with EKS Hybrid, and they release the updates and all that. But yeah, so how Cilium works is, whenever, for example, you want to call a pod from on-prem to AWS, the pod, this pod creates a network packet, and once it comes out of the node, CNI nats it, so that the IP source IP becomes the IP of node. Now it is out of the pod-to-pod network, it is in node network, which is routable. So once the network packet is out of the node and comes inside the AWS network, there the AWS CNI network is pod-to-pod routable, because that's how the VPC CNI works. Whenever a pod is attached, gets an IP, the IP is attached to a CNI available on the node. So that's why even if you call a IP from a different, maybe EC2 in the same network, you are able to call that, because it is on the direct VPC network. So that works. So that's why as soon as the packet comes out of AWS, comes in AWS, the VPC router handles the route tables and sends it to the specific node on which the pod resides. And once it is in the node, it gets to the pod. Now, how does the traffic come back? Because the pod-to-pod network from AWS to on-prem doesn't work. You remember we did SNAT here, or the IPNAT here. Here what we did now, in the network packet, the source IP got switched to the node. So whenever the pod returns the traffic, it has the destination set to node. So it will send the response to as destination to a node IP. It will travel back through transit gateway or direct connect, whatever you have, to the node, and then as soon as the packet is received at the node sees this traffic is for the specific pod which created the request, and it sends it back. So that's how the pod-to-pod network from AWS to on-prem, that's why it works. But the other way around, sorry, on-prem to AWS works, but the other way around doesn't. Any questions on this? All right, is that clear? Okay. So a few prerequisites for setting up a EKS hybrid network, which is first you need to have a direct connect or site-to-site VPN, as I mentioned, and the minimum bandwidth which AWS recommends is about 100 Mbps both sides, with 200 milliseconds of latency. And your CIDR should for the node CIDR, it should be in the range of 10.0.0.0 or 192.168.0.0, so that it doesn't go to a private or a public advertised IP. Apart from that, when you create a node on-prem, you have multiple options of deciding what OS to run on. Mostly what AWS recommends is Amazon Linux, Ubuntu, or RHEL. And they also have a support for Bottle Rocket, but it is Bottle Rocket maintained by VMware. So that works. And both your architectures, ARM or x86, is supported on that. Now, these are few firewall rules which we had to open, and majority of the communication and authentication works over 443, the HTTPS, between the control plane and the kubelets, so that it can give commands, instructions, and all that. Apart from that, there is one port called 10250, which is mostly handled by kubelet to share any logs, or when you do a kubelet exec command, the complete traffic goes through these ports. So if this is not available, your workloads will run, but you won't be able to see any logs or anything whenever you do kubectl logs and all that. And one of the most important is the port 53, which is used for DNS. Whenever a pod requests a DNS resolution entry, it goes to core DNS, and core DNS runs on port 53. So that is also required. So now, assuming you have created a EKS cluster with node port, remote node sider and remote port sider configured, and you have created an IAM role with all the permissions required on the hybrid, whatever permissions you need on a hybrid node. There are few standard permissions like a permission to join to the cluster, list access entries. Those are all given by AWS. And even in the Terraform module, they have a resource called hybrid node role, so that you don't have to worry about what permissions you have to add. So all that is handled by AWS. Any permission you need more, like accessing S3 or anything directly on the node, that you can configure on that role. And whenever we set up the hybrid node, you will have those permissions there. So assuming you again have a VM created, a basic VM with AL2 or Ubuntu, you just have to download a CLI called nodeadm, which AWS gives. What it does is it downfetches all the components required for running a Kubernetes cluster, which is kubelet, containerd, IP tables in case if it is not there, and all those kind of things. And it also downloads SSM, because currently you don't have a connection between AWS to on-prem for authentication. So it downloads that, and in the next stage, when you configure the node config YAML, you mention a activation code and ID. This is sort of like when you have used AWS CLI, you configure credentials, right? It is similar to that. So you get an activation ID and activation code. You configure that in this YAML with the name of the cluster which you are using. Yeah.
By the way, the SSM part will be done at the AWS side, right?
Yeah. So you create the SSM activation code and ID on AWS.
Yeah, but I think, like, as per I know, like SSM which only work with the EC2, right? On the AWS. And let's suppose if I want to manage the on-premise instance, but this is not going to work. So how we can issue like we got the issue, so how we can resolve that?
So the SSM activation code, what it does is AWS provides a hybrid setup for SSM as well. So even if you are not using EKS Hybrid at all and you want to manage nodes on-prem, they gave a service called SSM Hybrid or SSM on-prem or something like that, wherein it is a similar process wherein you create a activation code and activation ID. You pass that to, in this case, nodeadm. What it does, it uses that code and activation ID to find out which account you are linking to and what role this is using. So whenever you create that SSM activation ID and code, you have to pass what role permissions it needs to have. And whenever you run nodeadm install or init, it sees that and connects to AWS to see what all permissions are required. They have their own protocol or yeah. And once nodeadm gets that settings, it starts connecting to the node. It fetches all the CA certs which are near to join a node to a cluster, and post that, yeah, that's it. So go on.
Let's suppose if I had one VM
Mm-hmm.
and I directly want to install the SSL without the like directly install the SSL, so can I able to do that?
Yeah, that is possible. It is a very simple. They have a different pricing strategy for it. Like I think it is built at an hour or so, hour, and also on vCPUs, if I'm not wrong. But that is feasible. They have a very good service. I think hybrid or managed SSM nodes. It is something like that.
Tried with the light sale, but it doesn't work with the SSM. It doesn't work with the light sale.
A light sale I haven't configured in this configuration or this kind of setup, but SSM works. I have tried that out.
Okay.
Yeah. Even apart from EKS Hybrid. So we have, so we manage on-prem nodes as well for GitLab runners, where there we have used SSM managed agents. Yeah. We can connect later if you want. We can discuss about it. Yeah. Yeah. So coming back here. So once you have configured the cluster names, SSM ID, region, all that, NodeADM handles all the connection with AWS, bringing in permissions, joining the node, all that is done. And once the NodeADM init is completed, you have your node joined to the AWS, and if you do kubectl get nodes, you will get the node as ready. Yeah. Once the node is ready, you can start onboarding your applications just like a normal Helm install or whatever, and you just need to pass the node selector label which you have mentioned in nodeconfig.yaml, and pods can get started to schedule on that. In our case, as we went with a non-routable pod network, we had to go with a on-prem managed F5 or load balancer as well. We had that already, so we did not go through the hassle of setting that up. In our case, so once that is set up, the flow becomes, for example, if I want to call xyz.com, which is an app hosted on my EKS cluster, it goes to Route 53 to resolve the DNS to my F5 virtual server, that IP, to the IP of F5. Once it is resolved, the request goes to F5. It sees this packet is for my cluster based on the virtual pools I have configured in F5. We have configured two pools, HTTP and HTTPS. We have in prod we just have HTTPS because HTTP is mostly we are using it for debugging purpose in case HTTP fails for some reason. Once that is done, the request is passed through to the Kubernetes cluster, and all the SSL termination as well as routing is handled by Istio ingress. So Istio, you might know, is a service mesh. For our context, in case if you don't know, we are just using Istio as an ingress in this example. You can replace Istio ingress with Nginx ingress or whatever ingress you are using, Trafic and all that. And what ingress does it gets the request and checks for what domain it is meant for. Based on that domain, it just forwards that request to the pod which hosts that application. So if you see, XYZ resolves to Route 53, Route 53 resolves the domain to the IP of F5. F5 forwards the request to Istio ingress. Istio ingress checks what domain is it for. So XYZ resolves to an app pod, and it gets that resolution from the domains which you have set up in virtual service and gateway. Once that is done, you have the request to the app pod. So that is the normal flow you have. Just the new changes, this F5, your ALB gets replaced with F5. That's it, nothing else. And if you are on a routable pod-to-pod network, you can go with ALB as well. You don't have to manage your own F5 and all that.
So the F5 is managed manually right now?
Yeah. So they have a whole team which manage, because there are a lot of on-prem services which flow through it.
There might be some add-on which can manage it.
Correct. So in our case, we had to build a controller for it because the organization maintains a middleware to pass all the configurations to F5 so that it is not, users don't have direct access to it, they can control that access. But in case you have direct access, F5 provides a controller which does everything for you. Correct, they have. And even in future, we are planning to move to HA proxy. They have a more seamless experience of managing that. They have, I think there's something called HA proxy fusion or something, which is a newer offering by them, which integrates with Kubernetes very well. So you get a seamless, just like Carpenter, it becomes very seamless. So how did we reach that stage wherein the complete flow is working? During the whole setup, we faced a lot of issues. These are the four major ones we had to tackle. The first one was egress security and connectivity. In an enterprise, there are a lot of restrictions about what traffic comes in, what traffic goes out. It has to go through a proxy and all that. So to set that up, we had to jump a lot of hoops and do a hit and trial for finding out what domain should be allowed. Majority of the time, AWS gave us what network connectivity should be allowed between both the environments, but majority of our time went in discovering what should be allowed from the node to pull images or anything. For example, we had to see we had around 50 plus add-ons. So we had to see what all registries they are using. We had to get it whitelisted on our HTTP forward proxy. We had a lot of SaaS applications. We had to check with them with the support of their teams key. What all domains does your agent talk to, so that we can get that whitelisted on our proxy and all that. The majority of our time went there. The best thing we found out was get that documented, so that even if you move to a different environment, like in future we are planning to move from one hypervisor to another, we can just do these things there seamlessly. So we also built up a few Terraform modules to handle that in the proxies and all that. So yeah. Apart from once the connectivity was sorted, we started looking into how to place our add-ons. We started focusing on the major add-ons which we use, like we can say Argo CD, Keda. Carpenter was not required in our case because that's AWS only, and many others. We had to find out what all add-ons use webhooks to do their stuff, like Datadog uses admission webhooks, so that they can add their own environment variables, so that they can send applications can send data and all that. So we had to go through around 50 add-ons, so that we can decide what add-ons to place on hybrid, what can be placed on AWS. That also took again a lot of time, and we had to test all of them again. Once that was sorted, we started deploying our apps, and we started facing an issue wherein the core DNS was hitting a limit. So on AWS, whenever a DNS request is resolved on an AWS node, it goes through a flow wherein, for example, a pod requests google.com. So google.com request goes to core DNS. Core DNS passes it to its DNS server, which is configured on the node. For AWS instances, the configuration resolves to Route 53 resolver. Now, Route 53 resolver has this limitation wherein it can handle 1024 packets per second from a single ENI. So we started hitting that limitation. We had a connect with AWS, and AWS told we right now, till date, we have this hard limit or a hard quota limit per account that a single ENI can send only 1024 packets per second. So what was the suggestion which AWS gave was scale up the core DNS and make sure it is distributed across the nodes. And so we did that. Again, we started facing another issue wherein the requests from the on-prem nodes were going to AWS, which was taking a lot of time to come back, causing latency. So what we found out was there is a setting called traffic distribution in service, KTS service. What it says is, if we set traffic distribution policy to prefer close, it makes sure that whenever service is giving a pod IP or it resolves to a pod, it gives the nearest pod to from where the request is coming. So in our case, if a request is coming from hybrid, it should be routed to the core DNS of hybrid cluster, hybrid node. And if it is coming from AWS, it should go to AWS. We also started exploring a tool called, or an add-on called NodeLocal DNS. That did not work for us very well, so we went off with it. But it was a very good, thing wherein what it does is, instead of calling your end DNS server every time, it caches all the DNS requests. So on each node, you have a cache wherein if there is if your DNS request is already in the cache, it will just resolve it instantly, and if it is not, then it will pass it to core DNS, and core DNS will do its stuff. So that way, we can also mitigate this 1024 packets limitation, and yeah. In our case, we were having a few issues because of that connectivity from AWS to on-prem, and that did not work because of the way NodeLocal DNS works. But yeah, these were the major challenges we faced. Once we resolved these, our EKS cluster was ready to have apps, and we have deployed a lot of apps now. Many of them are running in prod. But during this whole process, the major thing which I learned was network complexity on-prem. So whenever you deploy a cluster or any app on AWS, the network connectivity is already sorted, handled by AWS. But when you come on data centers, you start to see small things like what is BGP, how is routing set up on our data center level, and all that. A cloud has made our lives a lot easier in terms of networking, but we start seeing these as soon as we start working with data centers and all that. The second was pod versus node level networking, wherein we had to decide if it is worth it to go with a pod to pod routable network in our case. And we found out setting up BGP is a lot of work for a network team. And for our use case, we will be fine with going with non-routable network. But if you are going with a greenfield project, I would recommend don't go with a non-routable pod network for a very seamless experience. It is always recommended to go for a routable pod-to-pod network. That way you don't have to worry about deciding what add-on goes where and all that. And that becomes a normal EKS cluster for you. You don't even have to decide कि ये nitty-gritties हो सकती हैं with EKS Hybrid, and you don't have to factor that while deploying your application or while building your application as such. Then was strategic component placement. As I said, we had to decide, do hit and trial, check with app supports if it has a webhook controller, if it needs to be in connect with the control plane and all that. Then was firewall bottlenecks. So हम लोग कुछ भी ऐसा cutting edge कर लें, कितना भी आगे बढ़ जाए, but data center teams will have their process, वो अपने time से चलेंगी. So what I got to know is कि अब अगर कुछ भी firewall का काम कराना है, get that documented first, get that checked a lot, and then pass it to firewall teams, because they will take their own time, and going back and forth with them will take a lot of time. Like in my scenario, it took around 1 week to just get these ports, like 6 or 7 ports whitelisted, because of the bandwidth they also had. So yeah, and the repeatable playbooks. Setting up even in AWS, setting up nodes is very easy, but on-prem, creating or setting up nodes might become difficult in case you don't have a repeatable or a dry process for it. In our case, we had to set up proxies so that all traffic goes through that. We had to set up basic things like installation of NodeADM, required like there are many endpoint protections like crowd security, CrowdStrike, and all that. So we had to create a Ansible playbook for those as well. Majority of the stuff was we already had because of data center teams. We just had to include a few things like NodeADM and few more components which AWS requires. But yeah, so yeah, that's it. Any questions? Right.
Have there been any challenges they faced in sort of upgrading the nodes themselves, because they're in different data centers and different places around the world? If
No.
You have to push a change to like the node itself, not the Kubernetes.
The way Kubernetes works is, it was very easy, because what we can do is, even if we want to roll out a new configuration change, what we could do was we can just add that in our Ansible playbook or a PowerShell script which you are maintaining for Hyper-V. That would just create a new node and join it to the cluster, and we can just delete the old one. So that way the whole migration is very seamless till date. And even the upgrades work the same way. You just upgrade the control plane and you just run our Ansible playbook to create new nodes, and the old nodes get decommissioned, because they are just VMs and ephemeral data is only there. So yeah.
What's the scale of the environment in terms of storage?
Currently, we are just running stateless applications. Databases and all that are still running on-prem. We are planning to migrate them maybe to AWS, or we are still exploring options because we are running Oracle on-prem. But in terms of nodes, we are running around, for a dev cluster, 30 to 40 nodes across multiple verticals. Like we have, I think, 4 or 6 verticals, like depending upon what application or what type of application runs. But yeah.
And in
Prod, I would say it scales up based on, for example, we recently had a Super Bowl event, so we increased the nodes to around 100 or so, and we also had to increase the capacity per node, because if we just keep on increasing the number of nodes, our Datadog cost also goes up because they bill on per node costing. But yeah.
And overall average storage capacity in general?
We don't. That's what we don't have any stateless data. We don't even have PVCs yet. Yeah, we are planning to introduce Ceph, but we are currently our apps are mostly stateless, so we are not focusing on that. We are the majority stateless data is being handled in DB, and yeah, no. And if there is a PVC level thing like Prometheus or anything, we are moving it to on-prem. Sorry, AWS.
You mentioned that to solve the core DNS limitations, you had one of the solutions was to have a local DNS cache.
Correct.
Right. I want to understand the kind of entries that were there, who was populating. I assume it was an automated, but I want to understand a bit more. And how was the cache validation being performed at that?
So, so for cache invalidation, first of all, I think that they have the NodeLocal cache has a configurable variable wherein you can set a time limit or a TTL for each entry. And what was the other question? How does the NodeLocal cache basically works?
Of the cache,
Huh.
and how that was happening, and yeah, that.
Got it. So each by default, if there is no local cache, CoreDNS gets a specific IP in all of the clusters. So it is a fixed IP. Even if you see your cluster right now, that will be a fixed CoreDNS IP. So what NodeLocal cache does is it gets deployed on per node as a daemon set, and it plays with the IP route tables. So what it does is, instead of whenever a pod requests creates a DNS request, instead of it going to the core DNS, it will have the destination as core DNS ka IP, but it will be, because of the changes on IP route table, it will go through NodeLocal cache. So NodeLocal cache will first check if it has that entry. If not, it will pass that or forward that request to core DNS, and then core DNS will does that. And as soon as it gets back the entry, it will store it in the cache, and yeah, later on whenever it is called, the first step will get the DNS entry and it will give it back. It did not work in our case because even the AWS pods were trying to request, what do you say, call the CoreDNS on AWS, and the traffic distribution does not work for NodeLocal DNS because NodeLocal DNS creates a stateless or headless service, and that's a headless service doesn't have this parameter. So that's why NodeLocal cache did not work for us. But if you go for again pod-to-pod routable network, that will work for you, for your case. And this will come if you have a very big cluster as well. So if you have a very high scale cluster, this issue starts popping up in a normal EKS cluster as well. So
Yeah, you mentioned that you were using multiple add-ons from the AWS. So was there any requirement related? You just want the add-ons on the workload nodes, not on the control plane node which is managed by AWS?
it depends. So if there is a component which needs to connect to your workload, for example, we can say, for example, Prometheus in our case. Prometheus needs to scrape metrics from the workload, right? So it needs to stay on the on-prem nodes because the network connectivity from there doesn't work. And any component which needs to connect to the control plane, that stays in the AWS node.
Basically, EKS only have the add-ons on the control plane level nodes. So
it can have on both. It depends upon you how you want to keep it. Yeah. We kept only the ones which are required on AWS and moved everything here so that we have a seamless experience with them having communication with the apps running on the nodes. But yeah.
How compliance is taken care?
Security compliance and all that.
PCI or HIPAA?
The HIPAA part or the mostly data regulation things are being handled because all the data resides on the on-prem things. Apart from that, networking and all that is being taken care of because of firewalls and all that. So I think all that is compliant because till date InfoSec team hasn't raised the concern to us. So yeah. Okay then. Thank you.